Google has released a new set of open source AI models, and they are called the Gemma 4 family. And these models are the latest addition to Google's growing AI lineup. Okay, now let's understand why open source models are trending. So open source AI models are becoming very popular right now. One of the biggest reasons is privacy. That is, you can run them on your own system without sharing data, right? And another reason is flexibility. That is, developers can easily customize and fine tune them for their own needs. Okay. Next, let's understand what's new in Gemma 4. The Gemma 4 family includes 4 different models, and each model is designed to handle different types of tasks. And on paper, these models look very powerful and promising. Okay. So with this background, let's break it down and understand what makes Gemma 4 special. Also, let's explore whether it really lives up to all the hype. Okay. So the takeaway is Gemma 4 could be a big step forward in open source AI. Why? Because it offers powerful, flexible, and privacy friendly models. But now let's see if it truly delivers. Okay. Now let's understand what is the Gemma family. So Gemma is a group of lightweight AI models created by Google. Okay, and it uses the same technology behind Gemini, but it is designed to be more efficient and easier to use. Okay, now let's understand why Gemma matters. Gemma matters because these models are built to run on everyday devices like laptops, consumer GPUs, and even smartphones. Okay, so you don't need expensive infrastructure to use them. Now let's understand what are the different types of Gemma models. So Gemma models come in 2 versions. The first one is base models. These are best for developers who want to customize or fine tune. And the other one is instruction tuned models. These are ready to use for chat, Q&A, and general tasks. Okay. Now let's understand the 4 different models in the Gemma 4 family. The first one is Gemma 4 Effective 2B. This one has around 2 billion parameters. It supports multimodal tasks, that is both text plus images, right? And it's built for edge devices like smartphones. Also, it is lightweight and efficient. Okay. And the second model is Gemma 4 Effective 4B. This one has around 4 billion parameters. It is similar to Effective 2B but more powerful, and it is still optimized for smaller devices. Okay. And the third one is Gemma 426B. This model is a mixture of experts model. This has a total of 26 billion parameters but uses only around 4 billion at a time. Okay. So that's why it is an efficient and also powerful model, right? And it can also run on consumer GPUs, especially with quantization. Okay. And the last model, the fourth one, is Gemma 431B. This model is a dense model with 31 billion parameters. Okay. And this model is the most powerful in this lineup. And this is best suited for advanced tasks, fine tuning, and research and development. Okay. And when it comes to context window or memory, Effective 2B and Effective 4B have up to 128,000 context, and 26B and 31B have up to 256K context. That means these models can remember and process much longer inputs like large documents or conversations. Okay. Now let's understand the benchmark performance. So if we consider across different benchmarks like reasoning, coding, math, and multimodal tasks, then Gemma 4 model significantly outperformed Gemma 3. Let me show the official benchmark results from Google. You can see the 31 billion model leads in most categories. Even the efficient 26 billion model performs very close to the top model. And also smaller models like Effective 2B and Effective 4B still perform well considering their size. So the takeaway is Gemma 4 brings powerful, flexible AI models, and these models can run on everyday hardware, right? That makes advanced AI more accessible than ever. Okay. Now let's understand the key features of Gemma 4. The first one is code generation. So Gemma 4 can generate code in different programming languages, and it performs well on coding tests like Live Code Bench. That means the Gemma 4 model has strong coding ability, right? So this model is useful for developers and coding assistants. And the second key feature is agent-friendly design. So Gemma 4 can be used in AI agent systems, and you can run it locally on your machine or self-host it in production systems as well. So you will be able to build real-world AI applications. Okay. And the third key feature is multilingual support. So the models are trained in 140 plus languages, and the models can understand multiple languages, and they can help with translation tasks as well. Also, these models can support global applications, okay? And the fourth key feature is better reasoning and advanced agents. So, Gemma 4 shows major improvements in math, logic, and reasoning. And this helps the model handle multi-step problems, planning tasks, and complex AI agents, okay? And the fifth important feature is multimodal abilities. Gemma 4 is not just text-based. It can also understand images, videos, and audio as well, okay? So we will be able to perform different tasks like OCR, that is reading text from images, speech recognition, and visual understanding tasks, okay? So the takeaway is Gemma 4 is a powerful all-round AI model. This is capable of coding, reasoning, and understanding multiple languages, and it can even process images and audio, which makes it highly useful for real-world AI systems, okay? Now let's see how to access Gemma 4 via Hugging Face. Gemma 4 has been released under the Apache 2.0 license, so you can freely use it to build applications and deploy it in any environment. And you can access these models through platforms like Hugging Face, Ollama, and Kaggle, okay? Now let's test the Gemma 426B model. For our demo, let's use Hugging Face inference providers to run it so we can better understand what the model is capable of. Okay, first let me show you how to create a login through Hugging Face. Let's go to the Hugging Face. Click on sign up. You will be navigated to this page. Then provide your email address and password. Click next and then complete your profile and click on create account. It's pretty straightforward. After that, you will get an email to confirm your email address, so make sure you confirm it. Then you will be able to log in and continue with your Hugging Face account, okay? So once you create an account and log into Hugging Face, then click on your profile on the top right hand corner and then click on access tokens. Click on create new token, select write, and then provide any token name and click on create token. This will give you the API key for Hugging Face. So once you have the access token ready, then go to Google Colab and click on secrets and then click on add new secret. Then provide the name as HF_token. This represents the Hugging Face token and enter the value as the Hugging Face token we just created. Okay, I'm using Google Colab as the code editor, but you can use any editor. Okay, now let's see the rest of the code here. First thing, we are trying to install the required package, that is the Hugging Face Hub, and then we are importing the login module from Hugging Face Hub and user data from Google Colab. Then we are reading the Hugging Face access token from the secret token and trying to log into the Hugging Face. Okay, here we are trying to build a fitness tracking web application. So this is the prompt we are using. Generate a modern, visually appealing front end for a fitness tracking web app using only HTML and inline CSS, no external CSS or JavaScript. Okay, and the page should include a responsive layout, desktop and mobile friendly, a navigation bar with logo and menu, etc. And these are the design requirements, and you can mention any constraints here and provide the goal. That is, what are you trying to achieve by using the Gemma model. Okay, so the goal is the final output should look like a real fitness app dashboard that could be used in a production level demo. So this is our prompt. Next step is send our prompt to the Gemma 4 model on Hugging Face using an API client and print the model's response. Okay, this is the Gemma 4 model we are using. After that, we are trying to display the model's response as a nicely formatted markdown. Make sure you run these cells one by one and observe the output. Okay, I already ran the code. You can see the model understood our requirement to generate the fitness web application. This is the HTML code the model generated. So I copied this HTML code into a notepad and saved it as a .html file, and then I opened it in the web browser. So as you can see, the output looks really good and the Gemma model seems to be performing well, right? You can see it created the navigation bar with logo and menu with dashboard, workouts, nutrition, profile, right? And dashboard section showing stats, calories burned, steps and workout time, right? And then we can see the workout plan section with cards like title, duration, difficulty, start button, and a progress tracker section with simple visual indicators like bars and a nutrition section with meal cards, right? So the model was able to generate the fitness app web application as per our prompt, right? And I will leave this Google Colab link in the description so you can play around with the code. Okay, so the Gemma 4 family looks strong not just on paper but also in real results. And it offers different models designed for different types of tasks and needs. And this makes it more flexible and useful for a wide range of applications, right? And with open source AI becoming more popular, we now have more freedom to test and choose the best models for our use cases, right? In the future, it will be exciting to see how these efficient models run on devices like mobile phones and Raspberry Pi, right? So the takeaway is Gemma 4 shows open source AI is becoming more powerful, flexible, and practical for real world use across different devices. Okay.